What's up YouTube? Thank you for spending a little bit of your time with me today. And if this is your first time here, welcome and please subscribe. Today we're gonna go over this particular problem together. Alright, so the problem goes like this. So we start off with 20 numbers and we randomly select 11 numbers. So we have no idea what are those 11 numbers except the fact that they are pulled from these 20 numbers. But we want to show that no matter how we select initially 11 numbers, you can select 2 numbers among these 11 numbers such that those 2 numbers are relatively prime. First of all, what does it mean for 2 numbers to be relatively prime? Well, it means that it has no common divisor except 1. For example, 2 and 3 are relatively prime because the only number that divides 2 and 3 is 1, but 4 and 6 are not relatively prime because 2 divide 4 and 2 divide 6. So before we actually solve the problem, let's get a feeling of what the problem is actually saying. We start off with we select randomly 11 numbers, so let's do that. So in my phone right here, I have a random number generator that will pull number from 1 to 20, and I have set it up so it pull numbers without replacement. So if you press the button 11 times, we'll get 11 numbers randomly from 20 numbers. And we're gonna see if we can pick 2 numbers that are relatively prime. Alright, so let's do the first round. 1, 2, 3, 11. Alright, so let me write that down on the board. So I have these 11 numbers as follow. So the question is, can we find 2 numbers that are relatively prime? And the answer is yes. Well, there are a lot of pairs actually, but actually the first pair, 11 and 14, are relatively prime. So this work for this random 11 number. Can we do it one more time? Let's try to do it one more time. Let's go. 1, 11. So we have these 11 numbers as follow. Can we find a pair that's relatively prime? Well, again, the first pair is relatively prime, as well as a lot of other pairs. Right? I'm gonna pick the second pair in this case. Right? These 2 are relatively prime. So we came up with 2 sets of randomly selected 11 numbers, and in both times we were able to select 2 numbers that are relatively prime. So it seems like it should be pretty easy thing to do. No matter how we select 11 numbers, there should be 2 that are relatively prime. But the question is, how do we know for sure? How do we know that among million ways to select 11 numbers, there will always be 2 numbers that are relatively prime? So let's prove that fact. So we're going to prove this problem using Pigeonhole Principle. And if you don't know what Pigeonhole Principle is, please check out my previous video on how to use Pigeonhole Principle to attack a problem. Alright, first step to use Pigeonhole Principle is we're going to define what pigeon is. And in this case, it's pretty easy. Pigeons will be those 11 numbers. Alright, here come the holes. And designing a hole is usually a tricky part. I actually will show you 2 ways to select holes. The first way will be straightforward way. You don't have to be very creative or come up with like excellent solution. If you fully understand how Pigeonhole Principle works, you can come up with this solution 100% of the time. The second way will be a little more tricky, but it will generalize to the higher setting. So let's dive into it. So to construct hole, you follow one simple recipe. You want to construct hole so that if you put 2 numbers in the same hole, it would imply what you want to prove. In this case, you put 2 numbers in the same hole, implies 2 numbers are relatively prime. So when you construct a hole, you want to make sure that when you put 2 numbers in the hole, they must be relatively prime. Alright, let's construct a hole in the following way. We're going to go down the list from 1 to 20, and for each number, we will see in which hole we should put that number in. Alright, let's start off with number 1. Number 1 needs to be somewhere. So let's just put number 1 in hole number 1. Alright, now we go down to number 2. Number 2, we have 2 choices. We can either put number 2 in the same hole as number 1, or we put number 2 by itself. And the rule of thumb is, if you can squeeze new number in the same hole as the previous number, then do it instead of putting that number in the new hole. In this case, you can put 2 in the first hole. And why can we put 2 in the first hole? Well, we go back to our most important rule. Our most important rule is we put 2 numbers in the same hole only when they are relatively prime. And are these 2 relatively prime? Yes, they are. So let's go to number 3. Number 3, we can put in this hole as well, right? And why can we do that? Well, two numbers in the same hole only when they are relatively prime. 1 and 2 are, 1 and 3 are, 2 and 3 are. So we put 3 in the first hole is fine. Let's think about number 4 a little bit. Should we put number 4 in the first hole, or should we put number 4 in a new hole by itself? And if you think that we should start a new hole for number 4, then you are correct. So let's imagine that we put number 4 in the first hole. Do we still follow our most important rule, meaning two numbers in the same hole only when they are relatively prime? So let's check that. 1 and 2 are, 1 and 3 are, 1 and 4 are. 2 and 4 are not relatively prime because 2 divide 2 and 2 divide 4. So putting 4 in this hole will be bad. Putting 4 in this hole make you not able to solve the problem. So the better way to do this is you put 4 by itself. 5, you can put it here. For 6, you cannot put it here because 2 and 6 and 3 and 6 are not relatively prime. Even here, you cannot put it because 4 and 6 are not relatively prime because 2 divide both of them. So 6 has no choice but be in a hole by itself. And then you can keep playing this game until you run out of numbers. So we go down the list all the way to 20 and we get this configuration. And you can check that if you pick randomly two numbers that in the same hole, then they are very relatively prime. So it's either two numbers in hole 1 or 4 and 9 or 8 and 15, they are relatively prime. So with this, you almost done because you just need to write down conclusion. What's conclusion? Conclusion is you have 11 numbers. You don't know what they are, but those 11 numbers assigned to this 10 hole, there will be two numbers that fall in the same hole. And by construction, those two numbers will be relatively prime. In conclusion, there will be two numbers among these 11 numbers that are relatively prime. Alright, at this point you might wonder, well, these constructions seem a little random. What if somebody give me 100 numbers and ask similar problem? How I can construct a whole systematically? Do I need to go down the list from 1 to 100 one by one and write everything out by hand? And that's where the second solution comes in. Alright, to understand how second solution would work, let's think a little bit on what properties would make two numbers relatively prime for sure. And the answer is, if you have two numbers that are consecutive, which means they're next to each other like 7 and 6 and 10 and 11, then those two numbers are relatively prime. So one way to construct a hole so that two numbers in the same hole imply relatively prime is to construct holes so that you put consecutive numbers together, right? Hole 1, I'll put 1 and 2 together. Hole 2, I put 3 and 4 together, and so on and so forth. And hole 10, I'll put 19 and 20 together. And at this point, you can just write down conclusion the same way you write down conclusion when you use the first hole structure. Alright, conclusion will be like this. There are 11 numbers with only 10 holes. By Pigeonhole Principle, there will be 2 that fall in the same hole. And according to the way you construct the holes, those two numbers that happen to fall in the same hole will be relatively prime. Alright, so that's all I want to talk about today. If you have any question, please leave comment down below and I'll make sure I answer all of your questions. And if you haven't done so already, please consider subscribing so you will not miss my next video. For today, thank you for watching. My name is Kuang and you're watching N Just K. Peace!